Hi everyone! Val and I got tired of playing chess, so we decided to play a different game using the same board and pieces. As mathematicians, we're trying to find out who has the winning strategy even before we start playing.
The game goes like this. Each of us will take turns placing a knight on the chessboard. So, for instance, Angela might choose to play her first knight here. Then, I may play my knight on any square that won't get it captured. Remember that knights move in an L, so I can play on any square except these 8. Let's say I play here next. That means that there are now 14 squares that cannot be played on, since 2 overlap. The first player who can no longer play a knight loses. So, if Angela begins, who will win? Feel free to take a moment to pause the video here to think it over.
To find the winning strategy, we will first consider a simpler game that we learned in our combinatorics class. This is how it goes. Val and I have an infinite amount of coins. We will take turns placing coins on a plate. The first person who cannot fit a coin on the plate loses. If I begin, then who's guaranteed a win? Feel free to pause again and try to guess. The answer is me. I will place my first coin exactly in the center of the plate. Then, for every coin Val plays, I can place my coin in the opposite place relative to the center coin. Let's call these two spots a symmetric pair. Each spot has exactly one symmetric pair, except for the center coin. So once I have placed my coin in the center, Val will only begin symmetric pairs, and I will be completing the pairs. This shows that for every coin Val places, I will always have a spot to place my next coin. In general, the first person to begin the game is guaranteed a win. Of course, if they place their first coin in the center. Cool! Now, how can we relate this back to our game? Feel free to pause again to give it a good think.
In this case, our center is now a vertex, not a square, so Angela will not be able to place a knight there. Instead, when Angela places her first knight, I can play in the opposite square, the symmetric pair. This will necessarily fall on a square because a square rotated 180 degrees relative to a point is still a square on the board. Now, I'm the one completing the symmetric pairs instead of starting them. But how can we be certain the pair to Angela's square won't land on a capturable square? We will verify that the symmetric pair to Angela's knight is not capturable by a previous knight or by that same knight. For starters, the capturable squares also have symmetry. So once a square is capturable by one of Angela's previous knights, its symmetric pair will also be capturable by one of my knights. Hence, neither square in the pair can be played on anymore. Secondly, we notice that the 8 squares a knight can attack are symmetric to the square of the knight. The center of symmetry in this case is on an edge, not on a vertex, so it will never be the center of the board. In other words, one knight cannot fill a whole symmetric pair on its own. Only 2 knights can. This has shown that once Angela places her knight, its symmetric pair is both open and is safe to play on. And so, we're done. I'm guaranteed a win.
So that's why Val lets me start the knight's game all the time. Now that you have learned new games and have their winning strategy, go play it with your friends. They will be surprised you always win. Thanks for watching!